Okay, so today we will be making the notes of this chapter, conservation of green fodder. So that is hay making and silage making, and these are my notes from which I am making my own notes, short notes. So let us start. So there are two methods of conservation of green fodder, that is hay making and silage making. Hay making, that is, and silage making. So if we add about the gist of these two methods, summary about these two methods, that involves drying. Hay making involves drying, and silage making involves uh, anaerobic fermentation, anaerobic or natural fermentation. So this is a gist of these two methods. Now, if we talk about this silage making first, silage making. So if we talk about silage making, then for silage making, what is important is how to define it. The process of making silage, the process of conserving green fodder as silage is called ensilage or ensiling. The process of conserving green fodder as silage is called ensilage. Okay, that is for ensilage. Acha, what is silage now? How will you define silage? So silage is a green material produced by controlled anaerobic fermentation of green fodder crop. Silage is a green material produced by controlled anaerobic fermentation of green fodder to preserve its natural components as much as possible. Okay. Now let's move ahead. So now we will write the process that we have written ensilage. What is ensilage? The process of conserving green fodder as silage is known as ensilage. And silage is a green material produced by controlled anaerobic fermentation of green fodder to preserve its natural components as much as possible. Okay. So wait. Now I think so it is okay. Yes, much better. I think so. So now what are the advantages of silage? So next is, from next page we will write advantages of silage making. Advantages of silage. Oh, why am I writing silage? Silage making. Okay. So advantages of silage making. If we talk about the advantages of silage making, then these are: first is preservation of green fodder near to its natural state. Preservation of green fodder near to its natural state. Okay, first point. Second point, weeds can be utilized. For silage making. Okay. Third point. If we talk about third point, then highly palatable. What is the meaning of palatable? Palatable means tasty or pleasant to taste. Pleasant in taste. Okay. If we talk about next point, so next is ensure. So since it's a conservation method, see, 2 points are there which are common in hay making and silage making both. So those 2 points are, that is, it ensures uniform availability of the green fodder to the animals throughout the year. So these are common in both hay making and silage making because both are the methods of conservation of green fodder. Okay. Palatable, that is highly palatable, that is pleasant in taste. So ensures green fodder availability to animals or livestock throughout the year. Throughout the year. Okay. Okay. And next point is control of parasitic diseases. मतलब parasitic diseases are also controlled. Parasitic diseases is also controlled here. Controlled here. Okay. Okay. Because why? Because parasites are killed during ensiling. Okay. Now crops suitable for silage making. So crops suitable for silage making. So if we talk about crops suitable for silage making, then these are, first is thick stemmed crops. Thick stemmed crops. Okay, thick stemmed crops. So first is thick stemmed crops, and second is these are preferred for silage making. Now second type of crop is the selected crop should be rich in soluble sugar or carbohydrate. Okay, so the selected crop should be rich in CHO or soluble sugar. Soluble sugar. Why? Why soluble sugar? Because soluble sugar will help in the fermentation process. If the sugar will be present, it will help in the fermentation process. Okay, so that is the reason. Okay, by the way, all these notes will be available in my Telegram channel. So the link for that will be in the description box. Now, what are the examples of such crops? So what are the examples of such crops? So examples are these examples. All the points are important because these are short notes. So maize, sorghum, oat, pearl millet, okay, hybrid napier. So all of these. So all of these are the examples of crops suitable for silage making. Okay. Okay. Now there are few more points. For example, there are more points. For example, should be low in protein, should have low buffering capacity. So crops should be low in protein. Crops should have low buffering capacity. Now what is the meaning of this low buffering capacity? Low buffering capacity means that, what is the meaning of low buffering capacity? Low buffering capacity means that the buffering capacity means the ability of any crop or any material to resist the change in pH. So low buffering capacity means that there is reduced capability of reducing the pH, resisting the change in pH. That capability is reduced. Okay, so there will be no change in pH. Why pH change is not required? Because for during fermentation, lactic acid will be produced, which will help in the conversion of green fodder, preservation of green fodder as silage. So that is why we need a crop which has low buffering capacity. Okay. 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 Now we need legumes. Legumes needed. Okay. 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 Now, what is the stage of silage making? Silage making. The stage of silage making is between flowering. So after flowering. Okay. Okay. Now condition for good silage. Condition for good silage. If we talk about condition for good silage, then diameter should be 25 to 35%. Okay, then dry matter should be 25 to 35%. Okay, no air, that is airtight condition should be there. Okay, and temperature should be 30 to 38 degrees Celsius in silo. Temperature should be 30 to 38 degrees Celsius in silo, inside the silo. So what is a silo? So if we talk about silo, then silo. So what is a silo? Silo is a receptacle in which silage is made. So utensil or any equipment in which silage is made. Okay, so it is a receptacle in which silage is made. Silage is made. That is called silo. Okay. What should be a characteristics of silo? What should be the characteristics of silo? Characteristics of silo. If you talk about the characteristics of silo, then these are: first is silo wall. Silo wall should be waterproof, should be impermeable to water. That is, should be impermeable to water. Okay, should be impermeable to water. First. Second, silo should be sufficiently deep. So silo should be sufficiently deeply situated. And what should be the depth? So depth is equal to 2.4 to 3 meter. Okay, this is the approx depth of the silo. And silo should be located on an elevated ground. Okay, should be located on an elevated ground. Okay, should be located on an elevated ground and should be sufficient to hold the silage as per requirement. The size should be enough. Okay, size should be enough. Okay. So these are the characteristics of silo. Now what are the types of silo? So types of silo, there are 4 types of silo. Okay, what are the types of silo? So these are pit, bunker, trench and tower. Okay, so these are pit silo, bunker silo, trench silo and tower silo. Out of these, pit and trench silo, this pit silo and trench silo, these two are very common in India. Okay. So these are the basic characteristics of the silo. Now what is the method of silage preparation? So method of silage preparation. What are the methods of silage preparation? Okay, so if we talk about the methods of silage preparation, then there is a following flow chart. So first let me explain the flow chart, then we will make that in this notebook, because this is a flow chart. So the first point is that harvesting the crop at 30 to 35% dry matter. So the harvested crop should contain 30 to 35% dry matter. Okay, then chop the fodder in small pieces, 2 to 3 centimeter size. Okay, let me write it down, then I will explain. Continuously, simultaneously I will explain. So the first step is, so let me write it in red. So harvesting the crop at 30 to 35% dry matter. Second, chop the fodder in small pieces, that is 2 to 3 centimeter in length. Next, add 0.5% salt to the whole ration or whole green fodder, 1% urea and 3 to 3.5% molasses, good. Okay, to improve the palatability. Molasses is good, jaggery. Improve the palatability, that is taste. Okay, so to improve the palatability. So what is the first step? The first step is harvesting the crop which is 30 to 35% dry matter. Second, we chop the fodder in small pieces, 2 to 3 centimeter in length. Add 0.5% salt and 1% urea and 3 to 3.5% molasses, and to improve the palatability. What is the function of molasses? Or these three, salt, urea and molasses, that to improve the palatability, that is a taste. Okay, so now fill the chopped fodder into the silo. Fill the chopped fodder into the silo. Okay, fill the chopped fodder into the silo, and after that press the chopped silo. Sorry, press the chopped fodder. Press the chopped fodder. Okay, press the chopped fodder. Add additives into the silage while filling. Add additives. And example of additive is sodium. What was the example? Sodium metabisulfide. Metabisulfide. Okay. Okay. Next is seal the silo with polythene bag. Seal the silo with polythene bag. Polythene bag. Okay. Next is put weights on the polythene bag or sheet. Put weights on polythene bags. Okay, put weights on polythene bags. Next is, last point is, leave it for fermentation. Leave it to ferment. For 45 to 60 days. Okay, so this is the complete procedure of silage making. Okay. Okay, so let us now move ahead. So changes which happen during fermentation. So how does what converts, or how does silage making, how is silage formed? How is green fodder preserved in the form of silage? So types of fermentation. Types of fermentation takes place. We all know that fermentation. So there are two types of fermentation which takes place during silage making. That is okay, sorry. So I don't know how that the flash is turned off. So no issues. So wait. Okay, so two types of fermentation takes place. What are those two types of fermentation? Lactic acid fermentation, and butyric acid fermentation. Okay, so lactic acid type fermentation by anaerobic lactic acid bacteria. By anaerobic lactic acid bacteria. Okay, by anaerobic lactic acid bacteria, predominant type. Okay, predominant type. And next, let me turn the page. Butyric acid. So if we talk about butyric acid, then by Clostridia, and predominant in those green fodder in which there is high protein and moisture content. In which there is high protein and moisture content. Okay, so these are two types of fermentation that takes place. Now, why do we need to expel the air out of the silo? Here I have written one point that we need to expel the air out of the silo. See, let me show you. I have written somewhere that point. I don't know where I have written, but I have written somewhere here only. Okay, so we need to expel the air. So why do we need to expel the air? Okay, why to expel air during silage making? Why to expel air during silage making? Why do we need to expel the air? So we need to expel the air because of the following reasons. The first reason being minimize the loss of nutrients due to oxidation. Minimize the loss of nutrients during oxidation. Okay, so if air will be present, that is oxygen will be present, so that will oxidize that substance, that will lead to a production of free radical, all of that, so that will lead to oxidation. Initiate the growth of anaerobic lactic acid producing bacteria. To initiate the growth of lactic acid producing bacteria. Okay, and next is to prevent the development of undesirable aerobic microbes, because we do not need aerobic microbes. Okay, to prevent the development of undesirable aerobic microbes and decrease the mold spoilage. To decrease the mold spoilage. Okay. So this much. Now let's move on to the types of silage or types of silage or characteristics of silage. Types of silage. So there are three types. That is, first is very good silage, very good quality silage, that is acidic taste, odor, free from butyric acid, mold and sliminess. Okay, so what are the characteristics of very good silage? The characteristics of very good silage are, that is acidic taste. Next is, after acidic taste, acidic odor. Acidic taste, acidic odor, free from butyric acid. Achha, why we do not need butyric acid? Because it degrades the quality of silage. Okay, and free from mold and sliminess. Okay, and pH is equal to 3.5 to 4.2. pH is equal to 3.5 to 4.2. Okay. Now lactic acid should be 1 to 2%. Okay, not that important. So basic done. So this was the very good kind of silage. Okay, very good quality of silage. Next we will move on to good quality of silage. This was very good. Next we will move on to good quality of silage. So second we will move on to good quality silage. Good quality silage. So if we talk about good quality silage, if you talk about good quality silage, then it means that acidic taste and odor, first. Second, pH is equal to 4.2 to 4.5. okay, and third is fair quality silage. Okay, fair quality silage, that is some butyric acid present. And second, pH 4.8 and above. So this was the basics of silage. I will upload this note in our Telegram channel. Thank you.